so much, and thank you for organizing. It's been really nice already, and thanks for having me. And so also thanks for the support, which allowed me to collect data, which is what I always like to do. This doesn't work, so that's awkward. I tried to click on it repeatedly, and where do I? Maybe I just stay here then?
No, it's definitely working.
It's not working. Okay, that's what I did.
Oh,
Maybe I'm just weak.
no.
Now it's working.
There.
Okay. So like I'll start with like why should we care about this, which is probably not I don't need to tell you here, but so women are continue to be severely underrepresented in academia and academic science, especially at top levels. And so I will show you data for both overall science and economics. And so that could be either due to a bunch of structural impediments, it could be due to a lack of role models, it could also be due to children. So I've been working on 3 areas mainly, and so the data that I've collected with support also from this initiative contributes to all of these 3 projects. So we're looking at children, also looking at the misallocation of talents across fields. So if we have time at the end, I'll tell you about that, and also bias, just straight out bias. When we evaluate people who have the same publications, the same citations differently depending on their non-productive characteristics. But today, because I was supposed to talk about children, I'm going to focus on children. And the data, all of these projects have are connected to one massive data collection effort, which is collecting biographies of American scientists, both men and women, and over a really long period in time, because we want to look at changes, and also because we're applied micro people, we want to look at, I want to exploit exogenous changes over time that allows us to kind of disentangle these different factors. So I've been collecting data from the American Men of Science for 1906, 1921, 1918, 1956, and 1973. The data I show you today mostly is going to be for 1956. And then once those data are, so that's like more than almost 200,000 biographies that we've digitized, that we're in the process of digitizing. And then we link all of those individually through machine learning and hand matching with alternative sources to measure productivity. So we're linking them all with patents, publications, and with census records. So census records are particularly helpful because they allow us to know the social background, the parents, the families in which people grow up. And so today, again, I'll focus on this, on women in science. Most of what I'm going to tell you is going to be 2 ways. So I will show you our causal estimates that we can derive from this larger data sets on all scientists. And then I'll show you data that we've specifically collected for this initiative on economists, which is going to be much smaller in scale. So I will show you kind of, here are the causal estimates, and here is what I can tell you about economics. So the big question that we're after here in this first stage is, how do children affect productivity? So there's a lot of data on earnings, but we know much less about the channels by which our children affect earnings. And so we'll specifically look at productivity. And so that's some of a really nice thing we can do about academic scientists, because we know we can measure productivity through publications. And then we're going to look at, consistent with the purpose of this initiative, we're going to look at how differences in productivity that I will show you are related to having a kid how those then affect tenure and participation at these higher levels. And then we're looking at selection. I'll show you that the people who survive, mothers who survive in science, are extremely positively selected. Okay, and so specifically, we're going to look at children as a cause of persistent underrepresentation. And so I think the one thing I will come back to is that the data that I'll show you are from a period in time when it was very clear who was watching the kids, right? It was like it was the women. Today it's more evenly distributed, and there's a lot of okay. Today men do more of the work, and there's also a lot of variation across different types of households. But still, in modern data, women continue to do much more of the child care related work than men. And so that's what we want to look at. And especially so after during COVID-19, there was this with school closing, survey data indicate that women were disproportionately affected by this change in economics and other areas of science as well. And so we can either kind of wait and see whether they survive in science, or we can try to predict these effects. And so what we're going to try to look at here is like, okay, if there is a disproportionate burden of raising children, so when I'll focus on the baby boom, then what are these effects? What does it do to participation? And I'll show you that the baby boom, when we had a disproportionate burden of raising children, it's pushed out a large number of women from the profession. Okay, this is the baby boom. It was mostly an American phenomenon, and Europeans did not have quite as many kids, but there are lots of kids, basically. And now I'll tell you a little bit more about the data. And so now I'm kind of through with and now at this point, ask questions at any point. So I'm happy to be interrupted with any types of questions. Rather hear you than me. Okay, so here is the data I've been collecting is drawn from the American Men of Science, which ironically also includes women. It was collected by James McKean-Cattell, who was a professor of psychology. He studied intelligence. He was the first to study to introduce the field of intelligence as a research field. And he wanted to have a very thorough review, a thorough database for his own analysis. And he was the editor of Science. So and he was the editor of Science for 50 years. So you can imagine, like, we all might have problems with getting a survey response. He did not have such problems. So when he asked his surveys, people responded. So he has like extremely high response rates on the order of 80%, when most surveys get 20%. And this is an exceptionally comprehensive data source. What he did, he started with a list of all scientific organizations. So if you're a member of the EEA or the AEA or anything like that, you would be in this data set. And then he went to catalogs of institutions of higher learning. So basically, if you show up in any catalog of a university, you'd be in this data set. And then he went through the contributions of scientific journals. So he looked at all the authors of scientific papers. And then he asked 2,000 people, have I missed anybody? So this is an exceptionally comprehensive data source on innovation, which we've been digitizing. So I'm just going to show you what's in the data with an example. So this is an example of Gertrude Bell Elion, a co-recipient of a Nobel Prize, super impressive person. I didn't know anything before starting this project. And so we have which is really important for women, we have the middle name and the last name. And we match that we use that to match people with their patents and with their publications and with the census record. We also have their precise birthplace and birth date, which is super helpful, again, for matching people with the census. For this project also, it allows us to figure out how productive are you at any given age. And it also allows us to control for changes over time, say, as there's societal changes that may make it easier for women in later cohorts to participate in science, have children. We also include that as well, so we can control for this, which is really difficult to do. Say, I work a lot with patent data, you have none of that information. And so we can append that here. And then the other thing we have, which is really nice here, we have the discipline and the research topics. And we use that to assign every scientist to fields. Because one thing could be that, say especially say we want to look at economics, we want to know who's actually an economist. And then we have the education. So we have the years of the undergraduate degree when people got their degrees. Something that's really exceptional about the 1956 data is that they are asked, hey, are you married? And they tell us, yes, I'm married in 1956. And they also tell us how many children they have. Again, that's something you can't really get from other sources of data, unless I'm matching people with a census, at which point I'm missing 70% of all observations. So here we know for all of the scientists, you're married and you have kids, which is critical for this project. And then when they get their PhD. And also this is really important. So they also tell us when they become assistant professors, which allows us to identify people who at least at some point tried to enter academic science. And then we also can see when they are no longer an assistant professor, when they get promoted. So we can look at when they get promoted, whether they get promoted. So we can look at tenure rates, and we can compare tenure rates across demographic groups. And also we can compare publications relative to tenure rates. Identifying female scientists, I thought this was much easier. It's like research is always a learning process. So my first thing was like, oh, let's just ask the data entry people to assign gender. Turns out that they're really bad at it. So what we have are actually, which is much better, we know whether people attended women's colleges, which in principle should be a good indicator of whether you are female like in this period. And so then we use that to check different types of assigning gender, different ways of assigning gender. And we end up using the data from the US Social Security Administration between 1880 and 2011, because we kind of need to know whether, say, Marion was now I would say, I was like, clearly a woman. Well, if you go back to 1920, it's a guy. So we need to kind of control for that. And then we're also horrible at identifying Asian names. So we go through all the Asian names and we assign them by hand, and we have a code for this. And then, so with that assignment, we actually can, so this is just purely the Social Security Administration data. We have much better assignment than manual assignment. And then we use the stuff that the topics that scientists use to describe their own research. We apply k-means to that, which is the most simple text analysis you can possibly do to assign each scientist to a unique research field. So what does that mean? So we take the text that describes a scientist's research field. Each scientist is a row, each word is a column, and then if that row shows up, if that word shows up in the words that describe your research, it's a 1, otherwise it's a 0. We downweight, the algorithm, the k-means algorithm downweights words that are frequent, like research, basically meaningless, and it upweights things like that are not so frequent, like germicides. And then we put 100 points into this giant matrix. The algorithm moves them around to minimize the sum of square distances until we have minimized the sum of square distances, and every scientist is assigned to exactly one field. Does that make sense? Like, so we always, when you do kind of text analysis, I always like to actually look at the data, so you would look at this as well. So I'm going to show you the example of aircraft. So we basically check all the data by checking whether the words in those assignments make sense. And this is kind of beautiful. The stability guided, all of that makes perfect sense. Why do we do all of this? Well, I didn't start out thinking I would do this. I would say like, oh, this is great. I can just take the discipline names. The discipline themselves actually miss a lot of useful variation. that only the k-means captures. So I'm going to show you this by 2 examples. So we have 2 people here. One says, hey, I'm an engineer. The other one says, I'm a physicist. When you look at the text of their research, what it shows you is they actually both, they study mechanisms to guide an aircraft safely to landing. And the k-means captures that. Whereas just me having taken it as the 2 disciplines, I would have said you're in 2 different disciplines. So by using this text, like, I think it's really nice that you can actually much better capture what people do. Okay, so now we match this with the publications. Publications are from Microsoft Academic Graph. Yeah.
Can you say a little bit about how you classify individuals who are changing self-field over time within their careers?
So actually, for this project, we just take it as given in 1956. So I have another paper on immigration, where we are more interested in changes over time. For the changes over time, we do something completely different, which uses this data here. So when you want to look at changes over time, you can't use 1956. You have to, well, I could now use 1906, 1921, 1956. That's still a little coarse. So instead, what you can do, which is a way more massive data exercise, we take the universe of publications in Microsoft Academic Graph. So Microsoft Academic Graph was an initiative by Microsoft that they stopped, probably wasn't profitable, and they put all their data online, and then we just kind of downloaded it. And now we're trying to, like, because it's so massive, we're trying to actually make it so we can upload it for others to use. And so what we can do there, we can use the text that describes scientists' research and assign them based on those publications in the year in which they published to a field. So the Men of Science just gives me snapshots of what people describe as their fields. The benefit of that is like super tractable. Right? You just have the keywords, very easy to handle. The publications have the benefit that they allow me to use to look at changes over time, but way more data, a lot of like keywords, some noise a little bit, not as easy to understand the whole thing, are super untractable, takes forever to run, but it gives you like more fine-grained changes over time. So if you want to look at changes over time, you can either do it coarsely, but very transparently with the Men of Science data, or not so transparently with the Microsoft Academic Graph. And so this is what the data used to look at, like what before Microsoft took it down. So we could add for each of them, this is for Gertrude Elliott, we just can take all of their publications. So we have a total of 820,000 journal publications by 70,000 scientists. Hilariously, I would always like to see who has the largest number of publications. So I'm going to tell you about the baby boom, and this is the guy who invented birth control. So put an end to it. Okay, and so this is, we're going to use the balanced panel of academic scientists. So we have 65,000 scientists that we can observe between 1900 and 1970. So we have to restrict the data just to keep it tractable. And we can observe them between the ages 18 and 45. In that data set, 50,000 of them are academic scientists. And so now I'm going to show you a little bit within that. I show you that, so we want to look at economists. So this is one of those points when I'm showing you, this is the data that we have for economists in this specific context. We have about 50,000 scientists in the academic panel, and of them are 2,600 are academic economists. But then when we look at women, right, the same problems that motivate us to study economists and study underrepresentation makes it also really hard to study underrepresentation, because we just have very few women. So we just have 116 female economists. And then if you do the math and think like, okay, how many of them are mothers, there are even fewer. So I'll show you the causal estimates based on the whole data, and then I'll just show you, like, look, economists look just like this. And then we have to kind of do a little bit of hand waving when we come to that. We use citations to proxy for impact and quality under the assumption that papers that are more highly cited, on average, are kind of more impact or more important papers. Now let me show you some results. So one of the really striking patterns that we see in the data is that mothers experience a productivity dip in their early 30s. The red line here is the median age at marriage for the scientists in our data. And so what you see is that actually sort of after 4 years, there's a decline in the publications only for mothers. What happens to mothers in their early 30s? So the median age of marriage, we can look at from the data because it actually tells us they got married in this year. The original data tells us this. But then to actually know when the children are born, I have to do the extra step of matching the scientists with their individual census records. It's harder to do for women, so we have to do this by hand. And we're also always going to lose people. So we do this 2 ways. We take the entire faculty of universities in California. So we hand match Berkeley, UCLA, Stanford, and UC Davis, and we match them all with the census record. And then we see how long is it before the average scientists have their first child. And so it's 4 years after marriage, and then with a median at 4 years. And then we also look at academic couples. So I'll show you some data on academic couples. So I match people with the census, and that's much easier when I have a man in the census. So I can I only need to match one of them to the census. And so I match all of these academic couples with the census. And so for 242 academic couples, I can look at when they have their kids, they have their first kid typically after 5 years, and again with a median of 4 years. So median scientist has their first kid after 4 years. And so go back, that kind of coincides precisely with when this productivity decline occurs. Do we see anything for men? Absolutely not. For men, nothing happens, right? Again, this might look different today, but because back then it's like women did all the work, there was no discussion whatsoever. But men actually become more productive during this time. Now I'm going to be able to show you again the data that we have for economists. For economists, you see the same pattern. They look like other mothers look like other women until they get married, and then when they get married, they start falling behind. And then this is actually something I think really striking, which is that what we see also in the overall data, and which kind of motivated us to do the study. Like mothers have this weird productivity uptick in their 40s, and they stay productive way longer than other people. And so the average scientist, up to, sorry if I blow some of our bubbles, I'm in that age group too. Productivity goes up to like 35, and then it kind of flattens out, and then it goes down. For mothers, this actually is different. They are productive late in life, and they stay productive. So this is for economists. Yeah.
So there is no selection here in the sense that everyone who's here is someone who published at least once, right? So it's not that this peak is driven by the survival.
Which could still be driven by survival, right? So it could be even that we have selection within the ones who are published, just a little bit less because we select on people who publish. But yes, you're right. I mean, I think there's still going to be some selection. Yeah. But it is a balanced panel, right? So yes.
How many non-mothers do you have? So are there many or?
So we have 130. So in the economists, we have 136. So I should have the exact number, but I would say it's like around 40. So not that many, right? So women in this period in time, and I think up to recently, just did the thing and just didn't have kids. Many women did not have kids. Okay, so now we're just going to look at this more systematically, but first let me answer your question. We'll look at those couples later. I'll look at couples more, the academic couples. So you're taking me forward, actually. Anything else? Yeah. No, it's actually, it's always, so we're gonna do everything. And I think that actually is a nice, it's a nice leading me back to what I would, to these regressions. So one of the issues is that for whatever reason, so we've done this for patents and for publications, women publish less and patent less. Now some of this could be bias. So what we do, instead of looking at comparing men directly with women, we look at changes over time. So we compare a woman, their productivity, we compare it with their pre-marriage productivity, and compare men with their pre-marriage productivity. And so that's what we're doing here. And so we're going to estimate OLS separately for demographic groups, separating this for mothers, fathers, women without kids, and men. Yes. Yes, this is why I tell you about the citation data before. And then we put in year fixed effects because stuff happens over time. And we put field fixed effects because, like, say, you can eat. Say, if you think about, like, say tenure cases, some fields just publish more than others, right? So IO, or like also this type of history, this is like everything just kind of takes longer to do. Then you'll publish less than, say, in some other fields, which is especially, I teach at a business school. There's a large variation in the number of papers that people publish per year. And so we're going to control for that. And then the age 26 to 27, which is the last year before marriage, is the excluded year. So I'm just going to show you that the patterns that I showed you in the overall data still hold when we're controlling for age and year fixed effects. And then for men, again, there's nothing. So why are mothers less productive? We already started talking about this. So this is something I had to kind of show myself, like, think about this. So mothers to this day spend much more time on childcare than fathers. So mothers spend about 2.8 hours per day, while fathers spend about 1.4. This is just an average. I mean, I always try to say this. It doesn't say that, like, none of you who are dads, I'm not telling you about dads, right? I'm just saying, on average, men spend less time than women. And now let's actually look at the effects. Let's try and kind of do our best on identifying causal effects. And so we're going to estimate event studies to understand the impact on children on marriage. And so the idea here is, like, it might be that mothers are systematically different. Say I might have children because I prefer children over research, or I might just be a slacker, and that's why I have kids. That is kind of evolves continuously. Whereas the shock of having a kid, the productivity shock of having a kid is very, like, just happens right there. And so I'm going to tell you, we are just going to look at this relative to marriage, because we don't know, except for the people we can precisely match with the census. We don't know when the kid was born, but we're going to say that the risk of having a kid increases after you are married. And then we estimate these effects separately for men and women. Yeah.
This was all before. I was just wondering whether the change some of the.
Yes, for sure. Yeah. So that's the Razi picture is on point there. That, like, once you can, yes. So that, and then work by Martha Bailey, for instance, has shown us that. And many others have shown this as well, that after that, I don't know the English word for it, but basically there's the pill click, that's the German word. So basically people have fewer kids once the pill is available. So there are the event studies. They look very much like the age studies, but now we're going to run an event study, and we'll put in age fixed effects because we know that age matters, and we put in field fixed effects, publication fixed effects. And the years -0 and 0 before marriage are the excluded years. And so what we see here this is now comparing mothers to other women and fathers to other men. That after 7 to 8 years of marriage, the publications by mothers declined by 42% compared with other married women. And so actually there's a slight discovery, and that slight recovery, which is driven, so I'm not going to have time to show you, but it's driven by women actually drop out of the labor force temporarily, so they don't publish at all. So they're driven by changes at the extensive margin, and then they kind of recover a bit. So comparing mothers to other married women. So why do publications by mother not fully recover? Sometimes people say, oh, but mothers have all this time thinking about research when they take care of children. I always find that surprising. But even if that were the case, I can have all this time thinking about research. The fact that I'm not interacting with people in the labor force means I'm falling behind on methods and other things. And so that actually is why we probably could expect to see an effect, and that should be particularly important in a field like science where skills atrophy very quickly. Right? So you just think about, we all learn about new methods from Twitter on a daily basis. Right? If you're not doing that, you're just going to fall behind. You're not going to write. You're going to have a harder time getting published. Okay, so now let's look at academic couples. So let me get back to your question. So academic couples are really interesting because they're kind of inherently different in some way, but they're a nice setting. Like, it's not clear how to think about academic couples ex ante. 10 minutes, perfect. Because we have two flexible schedules, so there's less really work. So if a kid needs to be picked up from the doctor or something like that, in principle, it could be either the man or the woman. So that actually might really benefit the woman. It could actually also be really bad if we live in a society where women disproportionately get less credit for work. Then if I'm in a sort of a rational household where I'm maximizing overall utility of the household, I might actually decide as the woman to step back a little bit, either willingly, I might just decide to step back a little bit and kind of help support my husband, either by taking on more of the housework, or actually, and I'll show you in our data, actually sometimes these mothers actually became RNAs for their husbands. So I think more extreme back then, right? I'll show you the extreme case, but some of it might still be going on. So we're just going to look at what historically happened here. And so here's one of these hilarious things where we did all kinds of really difficult text analysis to identify academic couples. And then I looked at Scott and I was like, Scott, it's like, we have their home address, don't we? And then it was like, yeah. And it's like, well, let's just see whether they live together. So basically we tried to do a bunch of complicated stuff. And then we realized, actually, let's just look whether they they live in the same household because we have their street address. And so by this, we had identified 684 scientists who married a fellow scientist. And so we have 312 couples in the balanced panel. So now we can run these same effect studies, but we're going to put in couple fixed effects, which brings us closer to what the literature on earnings does, because the literature on earnings, typically, these really nice papers that look at earnings within the family, they typically put in a couple fixed effects or family fixed effects. So now we're going to do the same. And actually, when we do that, we get exactly the same pattern as they did as well. So remember, when we're comparing mothers to other married women, we have like a recovery. But we were comparing mothers to fathers in the same family, there's no recovery. So there is actually, after 7 to 8 years of marriage, the marriage gap between mothers and fathers in academic couple has increased by almost 90%. And it stays there. Like, no matter what we do, they do not recover. So why is this? Like, this is one of my favorite examples. This is Albert Einstein and his first wife. And so they studied together at the AETH. She had much better grades on all the written exams, but failed her final exam, was failed by the oral exam. So she failed on oral, she did not get a PhD. She married Albert once he could provide for her, and he got a full-time job at the patent office. And then they start collaborating during this period. There's lots of letters that document this collaboration. In 1905, in the year after they had their son Hans Albert, that's Albert's miracle year. So he has 5 articles, a bunch of them, right? I will not like basically super productive. And he also comments on 21 scientific papers. So the letters document how Mileva supported this work, but she never put her name on it. And she actually said, when she was asked, why are you not putting your name on it? They even have a patent where she's missing on the patent. Why are you not putting your name? She's like, oh, but we're one stone. We're Einstein. So I will get credit through him. I mean, he divorced her, so that didn't work out. Married a cousin. But basically, when they wrote this work, she thought, oh, let's specialize, right? Let me actually contribute to your work. So he spends 5 weeks writing up this paper on special relativity, goes to bed for 2 weeks, and Mileva checks his work for 2 weeks, while also taking care of the kid. So now let's actually look what that does to tenure. And so this is another really nice thing of the feature because of the data, because we have our data on career progressions. And so we can actually look at mothers who are academic scientists when they get tenure and whether they get tenure. And what we see here is that mothers who are academic scientists are much less likely to get tenure. So 29% of mothers get tenure compared to 49% of other women and 48% of fathers. So other women look like fathers. It's just that the differences in tenure rates are driven entirely by mothers. I can also show you here, because we know when mothers get tenure relative to the year when they become assistant professors, mothers either get tenure early or not at all. So you either are super productive early on, but if you're not super productive early on, you're not going to get tenure, or much less likely to get tenure. And then, so one thing that I was encouraged to do, think about the policy implications. So one thing this data suggests to us is that we're much worse as predicting the productivity of mothers than we are at predicting the probability of men or other scientists. So basically, if tenure is a good bet, if we're good at it, there should be no differences in productivity after tenure. Yet we see that mothers' productivity increases after tenure, while the closest comparison group, other women, behaves more like what we typically observe after tenure, and that would be men. So for men, it kind of flattens out, whereas for women, it keeps going up. Also, mothers are much less likely to enter the tenure track. So whatever I'm showing you already is like conditional on getting mother onto the tenure track. But mothers already face a barrier there, at least in our data, in this historical data. So why is there a selection? So how are we going to look at selection? What we're going to do is we look at publications. We're going to look at citations. So mothers publish 1.1 times as much before marriage than other women. But also the papers that they do publish before they get married are much more highly cited. And there's no such evidence for men. Then mothers respond to this by just not marrying. So female scientists were less than half as likely to marry. 40% of female scientists married compared with 80% of men. And they also don't have kids. So 22% of female scientists had children compared with 74% of men. But then conditional on having a kid, they just almost have as many kids as men. So basically, once you have a kid, having the second kid is not as bad as like having that's really where the big jump is. So sometimes people, yeah. You know, I think that, yeah, it should all be on the same sample. So but it doesn't make a difference. So we did these graphs first on all of the scientists, didn't see any striking differences, but this is for the sample and the regressions. Yeah, so basically 22% of female scientists have kids in this period. So selection into research fields. So one thing, and that's actually what we're going to look at in this other paper, which I will not have time to show you. But there is selection into research fields. And often people say it's like, oh, women just don't like these fields that are harder. We look at this within the physical sciences, it's just not true. Okay, so women are actually overrepresented in these really hard fields like mathematical analysis and physics, because we think that this is because it's much more costly to discriminate when you're looking for somebody who's really good at math. And so just think about this is like the hidden figures, right? So you may not like the way they look, but when you really need people, you might put them in the back office, but you're still gonna hire them. Okay, 1 minute. So I'm just gonna show you the results on selection. So we wanna look at selection more carefully. So we have to figure out who survived to enter the men of science. And so to do this, we actually have to match the scientists with the census. And so what we do, we match faculty directories with the census, and we see whether women are more or less likely to survive the census, to survive to enter the men of science. And so I'm just going to show you this really quickly. Yes, so women are half as likely to survive as men. And so this is the graph actually that motivated me to start this research. So because what we see is that we kind of noticed there was this dip. If you look at the data here, basically this is for men, and kind of men act like these guys are too young to enter the men of science. But then what you notice is like mothers actually flatten out. And so if you think about if men and women had continued to grow at the same rate in participation as they had leading up to the baby boom, then science would have had in our data set, we would have had about 604 additional scientists. That's nearly 30% more. So there was a big loss in this generation of scientists where just basically they're missing women. We're missing women in the data. And you might just say, oh, it's just the men of science. So we looked at the census. In the census, this is even worse. So we take everybody in the census who is a professor, we do the same graphs. You see a much stronger effect for in the census overall. And then I'm just going to show you this like in economics. Again, we see the same thing. So actually, I have all these other slides afterwards, but I'm just going to stop here because I'm out of time. Thank you very much.
Right, amazing, Petra. We have a few minutes for questions as well. Just to say, for those who are online, you can submit questions in the Q&A on the Zoom. And for those here in the room, can you raise your hand if you're asking questions? We can give you a mic so the people online can sit here as well. So Petra, I'll let you choose your question.
I think you're waiting for the mic, but
Ready?
Okay, good morning. My name is Society. I have just one question, just to clarify, which is omitted variable bias. Probably there are some factors that may have flipped the outcome somehow, that maybe the impact of children on women productivity or scientists could have been different. So I don't know how you factor that into the study. Thank you.
we think about it all the time and try to minimize, right? This is why we are looking at, we're looking within genders, and we try to put in the field fixed effects. So we try to kind of figure out, and so I think what we really would want to see is are the women systematically different who survive in science, and that when we see they're positively selected. So are we missing something else? We might be missing other things, but we are controlling for as much as we can in terms of fields, in terms of the demographics. We're looking at within demographics, we put in the couple fixed effects. So the couple fixed effects actually are sort of the things that you would be most worried about. So one thing that I haven't had time to show you is that when we link people with the census, I also know how rich you are. And so this is actually much less of, kids are much less of a problem when you have a lot of money. Because basically what we look at is like when we match people with the census, there's one woman who survived as a mother from the Columbia faculty. We look at the entire Columbia faculty, we see who survives. And there's one woman, and she had about 3 times as much money as everybody else, and she had a live-in servant. So yes, there are some, so that there's some factors that we can't observe. And I think the couple fixed effects help us take care of that. And others we just look at within demographic groups.
I'm interested in whether we can learn something about how the career structures, how science is organized, interacts with this. Now, for example, in many fields, you have up or out promotion. If you don't get tenure, you're done. There may be other fields where there's still some ways of continuing in some other capacity. And so I was wondering if there's any variation across these fields, perhaps, or across time, that could tell us something about how the organization matters.
So glad you asked. So yes, so we're trying to do this in a paper. It's called The Misallocation of Talent, which I love the title. My co-author doesn't. But basically it's like, so we see that women systematically sort, they sort out of certain fields. And part of that is that some fields are less friendly to, like they might have up or out policies. So they're less friendly to having women take a leave. So we always talk about how horrible academia is, but industry is, in our data at least, much worse. So it seems actually that some of these women actually find refuge in academic science, because it seems like academic science on average is more forgiving. I have a different paper on trauma. Academic science is also more forgiving on like trauma. So if you need some time to actually recover from a traumatic event, academic science is much better than in industry. So yes, absolutely. There's going to be these impacts are going to vary across industries. They're also going to vary across fields. Some of that is going to drive this misallocation. And you asked for what we can actually do to estimate this. So this is for amongst inventors. This is what we see amongst inventors. It'll take 118 years to get equity. And so we're looking at these counterfactuals. And so the variation that we're using there is we're using World War II, which when enlistment for male scientists pulled men out of the labor force, they had no choice but to pull in women. So at some point in time, at least, you have women drawn into science and into different fields where they may not have otherwise gone, to actually take these spots. And when that happens, you see a huge shift in output. So basically this closing the gender gap comes from 118 years to 46 years just by moving people into these fields. So yeah, so that would be, I think that would be like, yes, moving people across these fields would really help.
We should probably